Let's discuss Snort, a powerful open source intrusion detection and prevention system, also abbreviated as IDPS. So Snort is one of the most popular open source intrusion detection and prevention systems. At its core, Snort is designed to inspect network traffic in real time. It analyzes packet contents and applies a rule-based engine to detect known threats or policy violations. So Snort can detect and block a wide range of attacks, including buffer overflows, port scans, web application attacks, and protocol anomalies. And in addition, it provides comprehensive logging capabilities, and it logs suspicious packets, events, notifications for forensic analysis, which can be conducted later on as well. And this is very important from the perspective of incident response and threat hunting. So Snort supports packet logging and real-time alerting, and it can output logs in various formats so that those can be integrated with other log analysis tools as well. One of the reasons why Snort is very popular is because it has super simple and easy to write rules. It has a rich set of existing rules, but you can also write custom rules very easily. So writing rules is super easy, and you can basically create rules for almost anything that you want, which makes the job of security analysts really easy when they want to tailor the rules to serve organizational policies or unique attack patterns. And that's exactly what we're going to discuss later in this lecture. So Snort has evolved across three major versions. So Snort 1 was the basic version. It was a basic packet sniffer with very basic intrusion detection features. Then came Snort 2. And this became the industry standard. It was much more advanced than Snort 1, and it was very widely used. It introduced a more scalable detection engine and support for preprocessors, but it was mostly single-threaded. Then came Snort 3, which is multi-threaded and a complete architectural overhaul. It was rewritten in C++ for modularity and fast performance, and it has built-in multi-threading, which was basically one of the blockers with Snort 2. Moreover, it also used custom plugins, Lua scripting, and other more advanced features. Moreover, Snort 3 has a much better performance in high throughput environments, and it is designed for modern complex networks. And we'll be doing a lab on Snort 3, the most advanced version of Snort. So Snort can be deployed at network parameters for external threat detection, or it can be deployed internally to monitor lateral movement or insider threats. It can also work in hybrid setups with other SIEMs. So SIEMs basically means security incident and event management software or servers. So it can also work with other SIEMs as well. Moreover, it can also be containerized with tools like Docker. It can run in the virtual machines. And so it has a lot of different ways that you can use Snort. So why should you learn Snort? So if you understand Snort, it gives you the insights on how signature-based detection works. You'll have practical skills to write and tune rules. And it will also provide you a strong foundation, even if you want to transition to another popular IDS or IPS. Now, one of the key reasons why Snort is so popular is because of its amazing rule syntax. It's so simple to understand, yet so powerful. So that's exactly what we're going to discuss now. So whenever you write a rule, the first thing is called rule action, which basically means that when this rule gets triggered, what do you want Snort to do? Do you want it to alert? Do you want it to drop the packet? Do you want to let the packet pass or reject it? So you have four different options. Mostly you'll be focusing on alert or drop. Alert would be if you're using it in IDS mode, and drop if you're using it in IPS mode. The next is the protocol. Okay, which protocol this rule should check? Should it focus on TCP, UDP, IP, ICMP? So for example, in this one, we're saying that check for ICMP protocol, which basically means it's going to monitor traffic which uses ICMP protocol. The next field is source IP and port. So the first part is the source IP and then the port. So basically you're telling that for a packet which is coming from this particular source IP and this particular source port. So basically it's going to ignore packets coming from other IPs or from the same IP but from other ports. But the interesting thing is that we have used any, right? So by any means that from any source port. So this is also something which makes Snort very flexible. So instead of specifying like the full range of ports, you can just put any. One more thing which I would like to comment is that this IP address, it can be a specific IP address, it can be a range of IP addresses, it can be an IP class also. So for example, you can also say 202.12.14.0/24, for example. So a whole network. And then for port, you can say any, you can give any specific one port, for example, port 80, 20, whatever you want to do. But you can also say for not from 443, then it means that all the other ports apart from 443, for example. So very flexible, very powerful syntax. Okay, so the next field is direction. So direction basically means this becomes the source and it is going somewhere here. So you can have incoming, you can have outgoing, or you can even have bidirectional. So you don't care whether, this is source or this is destination, or this can become the source and this can become the destination. So you can even give bidirectional operator. So this is, for example, the destination IP and port. Once again, just like source IP and port, where we could give a single IP, range of IPs, IP class, you can do the similar thing. So just to give an example, so you can say, for example, from this specific IP, any port to a range of IP addresses or full network. So for example, 111.1.2.0/16, for example. So it's very flexible. And this is once again the destination port. And then lastly, you have the rule options. So here's what does not need to display or put in the logs or show on console if this rule does get triggered. So this would be the message. And then you have something which we call as SID, which is basically sort of like a unique ID, which Snort requires you to have for every rule. So for example, if this is your first rule, then you'll have this one. If you define another rule, then you'll have to provide a unique ID, maybe 1, 5 zeros and then 2. Okay, so this is like the basic structure. Don't worry, we're going to do a lot of practice of these rules, so you'll have a good hands-on experience. Okay, let's have a look at a couple of rules which are going to clarify the concepts. So let me give you a couple of seconds to reflect on this rule. Alert, as always, we don't want to drop the packet. We're using it in IDS mode, intrusion detection mode. So we just want alerts. TCP is the protocol. It's coming from any network, any port. So basically we don't care where the traffic is coming from. We only care that it lands on this IP, that it is going to this IP address and this port. And the message is nmap scan to port 22. So this is what would be displayed if this rule is fired or triggered. And then we are specifying that it should have the TCP SYN flag, which is typically used in nmap scans. And then as always, the SID. So this rule gets triggered when someone tries to do an nmap scan of port 22 of this IP address. Let's take another example. I'll give you a couple of seconds to reflect on it. Okay, as always, we don't want to drop, we just want to alert. Protocol TCP coming from anywhere. This time, however, we're aiming for port 80, which is the web port. So message attempt to access admin panel. But here's the interesting thing. Now, rule options, this section is actually very wide and very flexible. You can add so much different stuff, so many different checks. For example, in this one, it's saying that does the content, which includes the URL also, include this thing? So for example, let's say your website or your online web application has an admin portal on which only specific people are even allowed to open it. So there's no login, right? So it's something which is automatically provisioned, and then people who are authorized, they can see it and open it. But if an external user tries to open it or a malicious user tries to open it, so for example, xyz.com/admin, then we want to be alerted. So this will trigger when someone tries to open your website.com, for example, or web application, whatever it is, /admin page from the browser. Or it could be from curl or anywhere. So that is another type of rule that you can provide if you want to get an alert if someone tries to open sensitive areas of your web application, for example. Let's see another example. Again, I'll give you a couple of seconds. So same alert. Once again, we are focusing on TCP protocol. Now, however, we're saying that any traffic coming from this network with the mask of 16 bits. Okay, so this is the network part. And then you can have any combinations of hosts here. Here is the interesting thing. We have used bidirectional operator. So we don't care. It can be from this network to this network or this network to this network. And any port here. And same, we have another network here. So it's basically TCP communication between internal networks. So in this rule, what we have demonstrated is that you can specify a network instead of specific IP address. Moreover, you can also use bidirectional operators. Now, intrusion detection and prevention systems usually have hundreds or even thousands of rules. And rules define what to do when malicious traffic is detected: block, allow, alert. Now, for Snort, there are two ways that you can use rules. You can obviously create your own rules manually, and it's very flexible. However, it also comes with thousands of built-in rules. And moreover, you can also learn from what others have learned, right? You don't need to really reinvent the wheel again. There are threat intelligence platforms who are always tracking latest threats, malwares, new types of malicious attacks, and they create their own rules. So you can even import the rule set directly from there as well. And in real world, in real organizations, this is exactly how it's done. We use a lot of rules which are already built in Snort, but we also import rules, and we periodically keep on importing rules from these latest threat intelligence platforms such as MISP, for example. Okay, I think we have covered enough basics of Snort and how to write rules. So in the next lecture, we're going to do some hands-on practice on how to use Snort 3 in Kali Linux.